In this video, we are going to take a look at how to pull a cloth around to create some interesting simulation, with the goal of rendering out some great slow-mo cloth movement. Because we want to render a thick mesh in the end, we have created a flat mesh in Marvelous and exported both the thin simulation mesh and the thick render mesh. Here we have the thin sim mesh, and to make this video production faster, it's just got 9,000 triangles. But the workflow is the same for a 9K, 90K or 500K simulation mesh. The first thing we're going to do is to duplicate the simulation mesh, as we want to keep a reference copy in the import position for when we later map it to the render mesh. We are going to drop this vertical cloth onto the ground plane and then pull it around. So now let's create a carbon cloth from the sim mesh, and that also creates a carbon simulation node. Let's set the simulation length scale to centimeters. To avoid this thin cloth intersecting itself, we will need 30 simulation subdivisions per frame to get the required level of collision testing. Now let's set up the cloth with a thickness of 1mm, i.e. 0.1 centimeters, to match the render mesh thickness from Marvelous. We'll leave the rest of the cloth parameters for now, and we can tweak those with different cloth behaviors once we have our scene fully set up. Next, we need to create the ground plane and turn it into a carbon collider. We need to give it a sensible thickness, say 0.5 centimeter. Let's now move the collider nearer to the cloth and rotate the cloth so it falls with a bit of an angle. Now let's reset the simulation, show the cloth and run a few frames. That looks good. As I'm going to run a slow motion render, I want to record the simulation with a lot of frames per second. So I'm going to change the FPS now to 240. Because we have a lot more FPS, now we can wind back the simulation settings because they are per frame. So 5 iterations per subdivision and 20 subdivisions per frame is going to be more than enough. Let's just check that that runs okay. Good. I'll just change the camera clip plane and then we can check for any interpenetrations. That all looks good, although it's clearly not super pretty, as it's a low-res mesh for demo purposes. It's good practice at this point to snapshot that output mesh to save having to rerun the sim to get back to this start frame. That will soon get very tedious with a high-res mesh. So we duplicate the output mesh and change the cloth settings to use the new start mesh. Let's just check again it simulates okay. So now we're going to grab this corner with a carbon welding and pull it with a carbon actor across the floor. Setting up an actor welding is very easy to do using the carbon macro. We grab some vertices in the corner here and then right click on the macro icon on the carbon shelf and pull down to the actor cloth welding. Yes, we're going to animate the actor as it's going to pull the cloth. Okay, all done. And to avoid issues while setting up the actor animation, the simulation is deactivated automatically at this point. So we set a keyframe on the actor here at frame 1, and then again where we want it to move to on frame 400. Let's go back to frame 1, reactivate the simulation, and run the sim. There we go, some nice smooth motion. Now from frame 400, I want to pull this other corner. So the same process again, grab some vertices, run the macro. We need to set a keyframe for the actor position at 400 and another one at 700. Now I don't want this second welding to activate until frame 400, so we need to keyframe the welding activation. 0 at the start, 0 at 399, and 1 at 400. Okay, reactivate the simulation and off we go. Here's a scrub of the result. Of course, we may want to deactivate the original welding at frame 400. There are endless activation and deactivation possibilities here. Now, as a final step, we will just add the render mesh and use the deformer. So we add the render mesh into the scene, and here is the render mesh, and you can see it's high resolution and it's also a volume. We select the output mesh from the simulation and the render mesh and click on the deformer on the carbon shelf. Now we just need to add the driver reference which is the original sim mesh position that, remember, we saved as simref. Reset the simulation, bring in some lighting and assign a material, and at the end of all that, we get this look. Here is a scrub through with the first welding being deactivated. We can bait this out now as a limbic and replay as needed with different speeds and camera angles to create the final look we are after. I hope you find that helpful, and thank you for watching.